In this video, we will be using the Impute tool in Alteryx. This tool imputes data. What that means is that it will assign some value to data that is missing from your source. In our case, we have a number of nulls. Now, these nulls represent that the person who curated or collected the data was unable to find any instances of babies being born with a given name in a given year. Now, in this instance, there is a reasonable real-world interpretation of what that means. If no data could be found saying that a baby was born with a given name in a given year, it is reasonable to assume that that means 0 babies were given that name in a year. This isn't always the case with imputation. Often you're going to instead want to use an average, because your assumption will be something along the lines of, oh, the user forgot to fill this in, we'll just assume they're typical. Or perhaps it'll be a group average. So they didn't fill this in, but people who are like them answered this way. We'll assume they're typical of people who answered other questions the same way. It's also worth noting, this data has nulls for the missing data or bad data that we want to replace. That isn't always the case. In some instances, you'll have a dummy code. So maybe the instructions given to people recording the surveys will be list a salary of -1 if the respondent refused to answer. It's important to know this about your data before you try and create rules for imputing so that you will make reasonable decisions. Now, why do we care about imputing at all? We care about imputing because there are some algorithms and tools that can only handle data of certain types. There absolutely are algorithms out there in machine learning and data processing and everywhere else that can handle nulls and do a reasonable job with them. However, there are other algorithms that just cannot understand it. There are things that will attempt to perform arithmetic and just get confused and lost when you try a null, and then will throw errors at you. So, in order to get the freedom to use this wide array of tools and get better interpretations, because we have more detailed and accurate data, we'll want to impute. To do this, we'll go to the preparation bar and then click on imputation and drag it down. You'll notice that the line is being drawn from the select tool to the imputation tool, while the line that already existed from the select tool to the browse tool still exists. Alteryx allows branching workflows like this. When this happens, it will just send the data out to whatever tools you have connected. You should be careful about this in order to make sure that you are considering, hey, is my workflow running slowly because I'm having it do a bunch of stuff that I don't care about anymore? If so, just delete connections or freeze the tool. Then it will no longer be passing data along and it will say, oh, I can't do anything here, I'll just ignore it. That'll speed things up because it isn't doing unnecessary work anymore. Now, back to the imputation tool itself. When we click on it, we'll notice that it has a list of fields that it can impute. These are fields that are of a data type that it could reasonably make approximations on, or that it has settings that it could reasonably understand. Numbers in our case. It could not impute a name because there isn't an average name or a median name or a default name. That doesn't make a lot of sense in context. Similarly, grouped names. What is the average between Allison and Hans? I don't know. It's not a meaningful question. What's the average between 4 and 7? That I think I can come up with. Now, the fields we want to impute are only going to be female and male. We don't need to impute the year because there aren't going to be any data points with a year missing. We don't have instances of, we know how many babies were born with a given name, but we don't know when it happened. So we'll just uncheck year. Next, we'll scroll down a little bit and double check what is it that we want to replace. In this data, we're replacing nulls. So we can go ahead and leave it at null. If you had it coded such as -1 means the user didn't respond, then you would have user specified value instead. Finally, we're going to want to see what we wish to replace the nulls with. Now, in many cases, average, median, or mode are useful values. You want to say that if we don't know the data, assume it's typical. But we have a little bit of external knowledge from the real world that allows us to give a better estimate or a better way to impute the data. We will want to select a user-specified value of 0. This reflects that 0 children were given a name in a given year if we have no data on any children being given a name in that year. Once we have all of this done, we're happy and satisfied with our tool. In order to verify that it works how we want it to, we'll go to In and Out and bring another browse up. Now I'll go ahead and click Run. It ran, it was pretty quick. And what do we have? Before the imputation tool was used, we have these nulls here. After the imputation tool was used, there are zeros where there used to be nulls. Everything looks like it's working right. That's always exciting.